Hi everybody, this is Ryan, and I'm back for another video for Newman Online College Algebra. This time I'm going to talk about week number 3. Specifically, I'm going to talk about section 1.3 in your homework. So week 3, much like weeks 1 and 2, look about the same. You have your overview and to-do list. Make sure you take a look at that. You have your instructor on week 4 videos. This is where I'm going to post these. I'll open these up in a minute. We'll look at the handout. You have 2 sections to do. You have homework 4 and homework 5. Your engagement activity for this week is very important. It's a check for understanding. It's essentially a quiz, and what I need you to do is when you open it up, it'll look like this, and here's a PDF. And what I need you to do is I need you to print off this PDF or work the problems on paper and send them back to me via email. So they look like this, and here's some directions right up here, but essentially it's like the problems you've been working on. And as you're working on your homework, if you have questions, please reach out and let me know, and I can help you through some of these things. But this is important because this will tell me how well you're picking up the knowledge and in preparation for your midterm exam down the road a little bit. But again, I'd like you to do these problems by yourself. Pretend they're like a test. You can do this multiple times. Turn in your best work. But I really want it to be your work and nobody else's work. Try not to get any help. My goal on this is to grade these. I'll probably make a video during week 4 and I'll go over these problems with you to make sure everybody understands how to do them correctly. But anyway, that's your weekly engagement activity, which is very different than what you've done in the past. We'll have some more of these as we move forward. Now going back to this, so this is week 4. I'm sorry, week 3. Right here. I want to come back up here and I want to spend a little time talking about our sections this week and go over the PowerPoints. I hope you're downloading these because they are pretty good. So let's download this. And again, your video will be sitting right here. Let's download this. And then we will take a look at it. So this first one deals with quadratic equations and complex numbers. So I'm going to just kind of walk through a few things on this presentation for you. The nice thing about these is that it's good notes. It shows some example problems that you can work out. So essentially there's 4 methods for solving quadratic equations: the factoring, square root, completing the square, and quadratic formula. We'll talk about those 4. I'll give you examples of each one. So factoring method. This is some notes on that. It's essentially we want things to be equal to 0 because anytime you have something equal to 0 and it's a product, like A times B equals 0, either A is 0 or B is 0. That's important. That's called the zero product property. We'll use that to help us solve these equations. So the first thing you need to do is you need to look at the greatest common factor. And that's the biggest number that's common to both numbers. So both terms. So here's the first term. Here's the second term. So factors of 8 are 1, 2, 4, and 8. Factors of 12 are 1, 2, 3, 4, 6, and 12. Of those, which is the biggest? Well, the 4 is the biggest number that's common to both. And then the x's, there's x squared here and x to the 5th here. So you have at least x squared common to both. So what that means is your greatest common factor is 4x. You can factor out 4x squared. When I say factor out, that's kind of like dividing off. So if you divide every term by the GCF, it'll reduce them. It's kind of like reducing fractions when you divide off the GCF. So if you take 8x to the 5th, and divide by 4x squared, you're left with 2x to the 3rd, and the 4x squared comes out front. You do the same thing with the other term. 12 divided by 4 is 3. X squared divided by x squared is 1, so you have just 3 left over. So that's the GCF. That's important. Here's difference of squares. So if A is a square and B is a square, it factors in this form. So an example would be 16x squared and 25y squared. 16x squared is a perfect square. 25 is a perfect square. So here's a little bit of notes. So 4x and 5y. So it factors into this form. 4x plus 5y times 4x minus 5y. And then you have basic factoring. Now, the thing about basic factoring is this. You want to look at this number right here, this term right here. And we look at the whole term, including the negative. We're going to think about what 2 numbers have a product of negative 36 that add up to 9. So product of 36, negative 36, that add up to 9. So if you think about all your different ways of getting negative 36, you have 1 and negative 36, negative 1 and 36, 2 and negative 8. If you think about your sums, in order to get a positive sum, your positive number has to be bigger than your negative number. So that's why we get to this one right here. This one right here. So negative 3 plus 12 is 9. So that is the one you're going to choose. So you're going to put your negative, so you're going to go x minus 3 times x plus 12. So you wouldn't want to go plus 3 and minus 12 because 3 plus negative 12 is negative 9. So it has to be, the 12 has to be the positive number because you want to get a sum of positive 9. Now on this one, you're going to want to combine some things. So this one, you'll solve this equation by factoring. So the first thing you need to do is, remember I told you a little bit ago we're going to use a zero product property. That means we want to get all the terms, we want all the terms on one side and a 0 on the other side of the equal symbol. So that's what we did here. So we moved the 8 over by subtracting it. If you look at 6x squared and negative 8, we factor out 2x, and that leaves your product. So you have a product of two things here. You have 2x, and you have 3x minus 4. They're being multiplied together, and they equal 0. So you think about 2x equals 0, and 3x minus 4 equals 0, and then you solve those two equations. So your answer is going to be x equals 0, or x equals 4/3. So you're solving these equations. So your solution set is 0, 4. 0 and 4/3. And then you can solve by factoring on these. Again, same thing. X squared minus equals 36. Move the 36 over, so your equation equals 0. Now this one is a difference of squares, x squared and 36. So you see how that works. And this one you're going to use the square root method, which you take the square root of p. Now I talked about the square root method. This is what the square root method looks like. When you have one side of the equation, that's a square, like this. So this part right here is squared. You can square root both sides. Remember, if you square both sides, you have to have plus or minus. So then you solve this equation. So this time you end up with 4 plus or minus 2 square root of 5 over 2. And so that which then reduces to 2 plus or minus square root of 5. Then here's your solution set. Now I want to point out something here. You see how we went from square root of 20 to square root of 4 plus, times 5? We want to break it into a perfect square times another number, and that's where, so the square root of 4 is 2. And 5 doesn't have a square root, so it stays underneath the radical symbol. Here's the process for completing the square. The big thing about completing the square is the coefficient of the x squared term has to be 1, so you got to divide it off. So you want the variables on one side and the constant on the other. So essentially we're trying to form a perfect square trinomial on one side, and the other side has the rest of the numbers. You'll factor the perfect square trinomial, and then you'll use the square root method. So here's an example. Notice how I have on the left side I have this term, and this term I have 0. Now, the reason we want to complete the square is because we cannot factor x squared plus 8x plus 4. We can't factor that. There's no product of 4 that add up to be 8. So that's where completing the square comes in. So notice the first step is subtract the 4 over to make negative 4. Then you take half of 8, and square it. So half of 8 divided by 2 is 4. 4 squared is 16, so you're going to add 16 to both sides. Now notice, this here is a perfect square trinomial. What two numbers have a product of 16 add up to 8? 4 times 4 is 16. 4 plus 4 is 8. So you add 16 to this side, 16 to this side, and then you just use the square root method to complete the problem. So here's some more examples. Now this one is the quadratic formula. This is what the quadratic formula looks like. And essentially, this one is just a formula that you just plug into. Like everything else, though, you have to have your expression, or this part here has to be equal to this part here. This side of the equation has to be equal to 0. This is A, this is B, and this is C. Now, one common mistake is you have to take the sign with the term. So B is +4. C is -1. A lot of times the mistake you'll make is this is -1. You'll just put 1 for C. But notice how C is -1. Then you just plug it in and you simplify. Now, complex numbers, if your radical is negative, you need to remember that the big thing here is, remember that the square root of -1 is equal to I. That's what you got to remember. Square root of -1 is equal to I. So what you do is you take the negative and you do this. You make it -1. And that becomes your I on the outside. Notice how it's on the outside. And then you have 28, which is 4 times 7. The reason you pick 4 times 7 is because the square root of 4 is 2. And don't forget your plus or minus. So you have 2 square root of 7i. Now the 7 stays underneath the radical because it doesn't have a square root. So this is your solution set. So that's your first section. I hope this helped you. Please refer back to these notes. I think they're pretty good. If you need help, please reach out. Talk to you later.